Right. Good morning, everybody. We're going to get started in just about 2 minutes. Just waiting for a few last folks to join on, and we'll do a quick round of intros, and we'll get going. Can you guys hear me? Okay.
Yes.
All right. Great. All right. Okay. Can everybody see my screen? Just.
Yep.
All right. Oops. Okay. Before we get started. Sorry, I'm just getting a little echo on the long end. Here. Is everybody muted in this room? Okay. Before we get started, just wanted to quickly ask if there is anybody new on the phone, for this is their first time on this call.
Yeah, I think this is my first time. This is Andrew Williams. Want me to introduce myself quick?
Yes, please, Andrew.
I'm a faculty at the Institute for Clinical Research and Health Policy Studies at Tufts Medical Center and do some informatics advising work and other kinds of things in the CTSI there as well.
Welcome, Andrew. Thanks a lot for joining.
Thanks for inviting me.
Anybody else? All right. Well, thanks to those who are returning, and for those joining in from uh, multiple institutions, including the folks from Celgene for sponsoring this work. It was great to see many of you at the Odyssey Symposium last week. For those that were on the Cooking with Clarity session 2 weeks ago, when Charity presented around the integration of Odyssey and unstructured data. Hopefully some of you got to see that in person at the Odyssey Symposium. So we were very excited to meet everybody. For today's session, we're going to be talking about APIs, and we're going to be focusing on the question of how do you leverage resources out in the world into Clarity. And this is going to be a presentation around integrating APIs, particularly RESTful APIs. But of course, many of the projects that we do integrate libraries, other tools, code bases, and so in previous, for example, when you saw Christine present around machine learning using algorithms, those are used by integrating libraries. And today's focus, again, will be more around the API side. Hopefully, by the end of this session, you'll have a sense of how you might take a resource from Amazon or Google or anybody else that has APIs using text and weave them into your ClarityNLP phenotypes. As usual, we've got documentation available on ClarityNLP here on our site. If you go to the main ClarityNLP page, we've also got our GitHub repository that walks you through how to get started. And we also, of course, welcome any questions both here live on our Slack channel as well as via issues on GitHub. So what I'm showing right now today is available this notebook that I'm describing. You should be able to get the current notebook if you go to our Clarity NLP page, and I'll put a little link in the chat box, and you go to notebooks, cooking. You select this one from 1024. This is going to be the notebook that I'm going to be presenting today. So I will put that in the chat window right here, and everyone is welcome to review it now or later. It won't run in the way that my version will run here, because I've got, of course, it's installed and running on a server. But if you're familiar with notebooks, you can download it and run it in a notebook server environment. Just as we often do, a reminder, once you get Clarity NLP set up, the process of ingesting documents to load things in can be done ingested via CSVs, or ingest via databases, or via custom processes. We also just wanted to note again, for folks that are new, that we've got several processes of running the NLPQL. Before we continue, I see we've got a few new folks who've joined. Jordan, thanks for coming on board. Robert, Yaron, Sergio, thanks guys for coming on board today. All right. The core of running the NLP queries does use something called NLPQL. I'd refer you to the documentation for it. But just so you know, there's multiple or three ways to run NLPQL. One is directly posting from an API server. One is using our user interface, which we'll also be doing somewhat today. And one is using Jupyter Notebooks. Using Jupyter Notebooks, we have a special library there. And so I'm going to just right now just load those libraries. Also, just ask if anybody's on the phone if you can mute, unless you have a question, and then feel free to unmute and ask those questions. Happy to take questions at any time. Definitely do not need to run through the whole thing. So I'm going to start this process by just loading in a couple of support elements that will support as we run our Clarity NLP today. I also have some secret keys for the APIs that I'll be using. So I brought those in a separate notebook, so I wouldn't have to just type them in here. But these keys are basically just importing keys that we'll be using. I wanted to focus our API example on sentiment analysis. So for those of you that aren't familiar with sentiment analysis, or have not had the pleasure of reading many papers on Twitter, sentiment analysis, and so forth, this is basically the gist. You can obviously read up on about it, but it's essentially looking at bodies or snippets of text and developing some score in terms of its sentiment, positive or negative, and other aspects of that. So sentiment analysis is not rare. It's a very commonly applied technique. If you go to Mashable or some of the API trackers, you can see that there's right now 138 sentiment APIs that are out there in the world. So there's a lot of different ways to process sentiment and to be able to look at text. And so today we're going to run through a couple of examples, but what we're running through should essentially apply to any cases. Close that. So I wanted to start with an example from Microsoft Azure from their text analytics. I'm just going to kind of click on over there and just sort of show you guys a little bit about the starting place. So Microsoft has a kind of a pretty light text analytics set, but they've got a few different things. You can put in documents, and you can retrieve results to get back, for example, the entities in a particular document. You can get back key phrases that it parses through, or you can get back, in the case that we're going to be using, sentiment, where you get a score. And as you can see here, typically a score near 1 would be positive, and a score 0 would be negative. And that's essentially the way that the Microsoft RESTful API works. You pass in a document, you actually have to specify the language that it's in. and then it will return back the score. So it's pretty, pretty, I guess, straightforward from an API perspective. And here's just an example in our notebook, just to sort of show you where I put in a text saying I am really disappointed, just into Postman, and I put in my Microsoft credentials and I sent it, and it came back with a score of 0.003, so pretty negative. And you can see the way it's formatted there. Um, if we want to try something um, a little more upbeat and see what Microsoft gives us, in this case, I've done the same thing. I've got a post to this particular URL, and I've got a set of, I am really delighted is my new text, and it comes back with a 0.992, apparently a very, very positive score. So completely independent, of course, of this of Clarity, you can go to using Postman or using an API tool of your liking. You can go through and you can put in different documents and different kinds of notes and see what scoring you get. It's fun to play around with those scores. I actually did I am super mad at you, which was a 0.14, where I am not super mad at you was a 0.03. So, whether it's accurate or not will be a conversation for another day. But its general utility as an example of how you would use text analytic APIs, I think works pretty well. So let's take a look at how we would build uh, a um, a custom task and an ability to take a phenotype to ask a question about a sentiment or a sentiment in a clinical document using Microsoft's sentiment API. And now we're going to dive in a little bit to some of the coding aspects, and we won't be manually typing it in, but I do want to walk through the components of the code to make it as easy as possible for other people to be able to replicate this. So typically, one of the best ways to build out a custom task to extend something like an API is to use one of the templates that we have available. And so we have a nice custom template that you can use in our custom task, which is a sample API task. It's in our Clarity repo, and it's a sample API task that, in this particular case, makes a Chuck Norris joke randomly selected for every document that you pass into it. And so it has an API out here, which someone has kindly contributed to the world, that basically creates a random Chuck Norris joke for anything you pull in. And what this task basically does is it passes in documents and it returns back these jokes. The key thing about what we're doing, and when you look at this sort of API task implementation, it seems a little bit complicated, but really the key part is just this middle part right here. And so I just want to focus on just the very middle part of what's happening in this Chuck Norris template. Basically, what it's saying is that for every document that I have, and in the particular case here, this self.docs refers to the document set that we've passed in to it. So for those who have been on our previous calls, you've sometimes seen us create document sets, and we have a very extensive prior cooking class that I'll just very quickly link to if you haven't seen it, where we talk about document sets. We talk about how to create document sets, and that's the September 12th cooking session. And basically, what you'll see if you go back there is that you can define document sets by a query, by report types, by report tags. There's all kinds of different ways that you could generate a document set to find what you want. So we're not going to focus on the creation of document sets today, but if you want to refer back to that cooking session, it will give you all the information you need about how to define a document set that you then name and characterize. In this particular case, we're basically saying that someone has sent us a set of documents. However they created it, and we would like to do the following things. We'd like to post a request up to this API, and then when we get the results back, we want to store that. We want to take that back as a joke, and we'll look at the format of output and how we combine that. And we're going to put that and write that back to our results there. So more specifically, for every one of the documents coming through, the task will call up those random jokes and we'll write it back. So let's now change our API call a little bit to match what we saw with the Microsoft Azure API. So I'm going to switch over to this API location, and let's just quickly do an Azure sentiment here. And what you see is I can send in one of these documents, and I'm going to say, I am very thirsty. I'm just putting in the document, and it comes back and it gives me a score. The reason it did that, and I won't linger on these passwords or whatever, is that I have some headers here that provide information. Specifically, is the content type and my subscription ID to Microsoft. And because I have that in what's called the headers, it's willing to take the document that I have and it's willing to return the results in this particular format. So if we go back to our scenario here, then what we would say is, well, this Chuck Norris cooking thing is pretty cool, but I want to make this work with the Microsoft Sentiment API. So I'm going to create a variable called headers, and I'm going to put in that content type, and I'm going to put in what is in the Microsoft documentation as the required header for my authentication. So I've got this subscription key, and I've got this documentation. I've got my subscription key entered here. I also want to put in my, I also want to put in my payload, which is the body of what I want to send over to Microsoft for them to look at. And Microsoft has a specific pattern that they want. They want the language, they want the ID, which I just made up as one, and they want the text. So I am going to create a payload, which is just that exact JSON. But in this case, I'm going to substitute text for the doc or the document. You may recall that we called the list of documents for doc in self.doc. So that's referring to one of the contents of our document set. So I'm basically saying, take this body, pass along this as my payload, and then finally, I'm going to ask Microsoft, or I'm going to ask this task to post to the Microsoft URL, the headers, and the payload that I'm looking for, and I'm going to wait for the response. So basically, whenever you're creating or want to integrate a new RESTful API, you just need to know what are the headers I need, what is the body or payload that I want to send, and then you send it. Some, like Chuck Norris, don't require keys, and others like Amazon, Microsoft, Google typically do require some kind of keys. Some require payloads and some don't. The other thing we need to do, which differs from Chuck Norris above, we got a joke back, and we said, okay, well, we'll take that joke and we'll write that back in. But in this case, we need to change how we handle the API result. So in this case, if I go back to my query and we got the result back, you can see there's a particular format that it comes back in. It has documents, and it's got an array, and it's got a score, and if there's any errors, it produces the errors. All of this is in the Microsoft documentation, so that if, for example, you have another RESTful API, you can just go to their API documentation, look at an example, and say, what's the format that I'm going to be getting my results back in? And so what we've done is I've looked at that here, and I've said, well, let me change let me get my response back, and I'm going to call it the response to what we submitted before, and I'm going to take the documents. In this case, I'm taking kind of a shortcut, and I'm just picking the first document because we're only sending one document at a time. You could iterate through, but I just kind of kept it simple. And then we're getting back a score, and so I'm saying I would like to add to my object, which is what I'm going to write as my result into Clarity, something called sentiment score. And that sentiment score, I'm going to pull from the response back that I've received from Microsoft for their value of score. So essentially, I'm taking those elements and I'm going to pull that back to write it as a result. The last piece to note, and this goes back to this question about keys, is that there's different ways that one could imagine using API keys. One is that you could build it into your system. the approach that I taken here is I'm letting the user in their NLPQL pass in their API key directly. And the reason that this can be handy is that it's independent of the system. You don't have to program the key in each time. But the downside, of course, is that your API key is then part of your public NLPQL record. For the purposes of this demonstration, we're just going to say we're going to pass the API key in. And so there's a little bit of logic that you can do in Clarity if you want someone to have a custom element like an API key or anything else you want to be a custom parameter for a particular function. And that is here. It's called the pipeline custom arguments, and I'm picking API key. So all of this is to say that I'm now taking this whole thing and saying I want to create my headers. Instead of writing XXXX for my key or typing it in, I'm saying take the API key that was passed in by the user, take the documents, send them all out, and then write the results back. So we've done this whole thing. I've got the final code up on GitHub for this. There's a couple additional elements that we did, just minor things, wrapping it back together and using sentence lists so that, for example, we didn't pass in every single word. Every single document as a whole, because a whole clinical document has got a lot of information. You might only want the sentences, presumably, that you're looking for, so we could have sentences that are more specifically targeted and look at it sentence by sentence instead of passing a whole document. So we've done a lot of preparation to get to this place. I must have taken out one last thing, which is that once you've written your code, you just have to put that code in the custom document in this custom task area. So in Clarity, there's something called custom tasks, and if you in your version home locally, you add any kind of Python to the custom tasks, it will automatically get inserted and added to the custom task list, and then you can call it in a phenotype. So this is my version of the NLPQL, and basically what we're doing here is we're basically saying, and this is a kind of a pretty random one that I just put, but we can edit or do different things if people want to try different looks. As I said, I want to look at sentiments about birds, and I've created a very simple phenotype, how we feel about birds, and I've included the Clarity library as we always do. And I said I have a term set that I want to call birds, and that contains the words bird or birds. I'll take a quick moment here for those that weren't at the previous cooking session where we talked about how to do expansion, but you may recall that there's some nice nifty little expansion tools that we've built into Clarity. So I think if I do Clarity dot plurals or synonyms or things like that, I can sort of more automatically build this out. So I've done I think this will expand automatically, as you saw. I just typed in plurals and so forth. So if you didn't want to go through all the trouble, or you wanted to use synonyms and things like that, this would be the place where you would do that type of thing, where you would implement synonyms and plurals and so forth to have that happen automatically. But for this demonstration case, I've just said take bird or birds, and I want to pass this birds search to our new Azure Sentiment custom file or custom task that we just built. And I'm going to pass in the API key that I've, again, for the purposes of this notebook, put under an Azure key variable, but you could put the key in directly, and we're going to run it. So I'm going to just hit run, and what you can see is it's now just submitted a job. That job was called How We Feel About Birds, and if we go to our result viewer, you should see that there's a now How We Feel About Birds effort in progress. And I can look at the Luigi results, and I can see that there's some tasks that are running, and I've got this Azure Sentiment task that's cooking along. It's doing its job. It is looking for bird or birds, and it's passing it along. I guess it finished in the time that I was running, but basically what it's done is it's taking the task that I requested of it, and I said, go through and run it. and it will then go get the results for how we feel about birds. And if we look at these features here, we can see that I've got a number of bird feelings that have returned, and that we have these notes: alert and oriented at beginning of shift, but seeing birds. And IBM has given this. I'm sorry, Microsoft Azure has given this a zero point 0.5, neither negative nor positive. This person's seeing flies, cats, and birds, which seems to be a positive thing. This person is having some tremendous ragtime visual hallucinations, seeing birds, which seems to be very positive things per Microsoft. So I'm not sure how they rank. They seem to find the agitation around birds flying around the room being a negative here. And so I don't mean to make fun of this sentiment analysis. I know it's a hard thing to do, and the data scientists in the room will tell me that it's not easy to do sentiment analysis. I don't want to criticize, but I just want to point out that what you see here, which is pretty cool, is that we were able to go and basically say, take a look for bird things, and come back and bring us results and score those sentiments. And it has gone through the whole process of pulling out documents, parsing the documents, getting all the great stuff, dates, and all the stuff you get, just with Clarity in general, what kind of a report, and it's gone and it's done this document parsing for birds. And presumably, if I add, one other word, never a good idea to do this kind of thing or running, but something kind of rare because I don't want to look through like a million things. But let's take like football or something kind of weird. It should, in theory, if I just rerun it, do the same thing, but for sentiments regarding football. So I should have changed the name because it's still called How We Feel About Birds. Probably should have given it a little bit of a better name there. Presumably, this top one is now How We Feel About Football, and you can monitor it with Luigi if you're just kind of like eager. But basically, this Clarity takes care of just kind of keeping track of stuff, so um, you don't have to do that manually. So looks like the job is now done, and we'll see if we got any results about how we feel about birds here. We did. This is football feelings. I should have changed the name, but here you can see it. Nursing other. Mom demonstrated good positioning using the football hold. So some of you may be familiar with little babies, and that little babies need to be held just so. And that's done. And here we have a lot of things about football hold. Actually, that seems to be amongst the major use of football in here is nursing notes and so forth. So obviously, with unstructured data, there's so many amazing things that you can discover and explore. But here's one that's less good. Somebody was playing football, which is kind of what I was expecting, and they fell and they hit their head on the concrete and had loss of consciousness. And Microsoft was kind to return that API score at 0.17, so kind of a negative thing there. So you can see that what we've created and why it's powerful to do what we just did is that we can leverage all of the functionalities from term sets and document sets and cohorts and all these other cool things that Clarity can do, but now we can add this nice sentiment function that came back. And so that's an example of how that gets integrated in. And this is where you put it in. Now, I'd like to try an example of one more API, just so people can get a feel if they build their own, how it might differ. And this is going to be the Watson Tone Analyzer. The Watson Tone Analyzer is also pretty cool. I'm going to close a few windows here because I got all these things open. It differs a bit from Microsoft. It's a little bit fancier in the sense that what the Tone Analyzer does is that it actually will go and it will, let's just do our own text example. I am very excited for birds, and I can analyze it. And what it does is it comes back with joy. And it actually gives me, I'm going to view the JSON since all of us here are a little more hardcore than this. It gives me the JSON. It actually says there's a tone name of joy and there's also a tone of confident. And it gives me scores along those axes. So if I actually write something really bad, like I am very worried, and we analyze it, it should come back with sadness, but a high score on sadness. And it also comes back with a tone of fear. So this differs from Microsoft in that a 1 does not mean positive and a 0 means negative, but a 1 means it's very much whatever the tone that's being referenced. So this is very sad, or pretty darn sad, extremely fearful, and also apparently very confident as well. So if I am somewhat worried, I can assume that my confidence level will drop. Yeah, I'm tentative now. So rather than changing the confidence level, they've given me a tentative tone, but I'm still fearful, but a little bit less when I was very worried. I'm now somewhat worried. So you can see this is kind of a pretty cool API, and it's a little bit more sophisticated than what we were getting back from Microsoft, but also somewhat different. So this is just me showing those examples as above. Watson providing the scores, providing the tones for these things, and I don't want to go back through the code process from beginning to end, but I do want to highlight a couple of the key elements, which was we need to review the headers that IBM requires. And it turns out that IBM requires an authentication key and an API key, which you get when you register for the IBM or the Watson APIs. And it also has the body that needs to get passed in, which is actually much simpler than Microsoft. And it also has a result format, which is somewhat more complicated than Microsoft. And so we did exactly what we did before. All of this is just exactly what was done before. The only difference being I've now added a few new things to my headers. So I've got an API key and I've got an authorization. In order to do that, I now am expecting the user to pass that information along in their NLPQL. I have the same stuff, the sentence, I've got my post, everything else is exactly the same until the results. And now I need to handle the results a little bit differently because of the fact that these are tones. So I'm taking the response and I'm saying, give me those tones, and I'm going to store the tone name and all those kinds of things again. And now I'm gonna result. So this is the same thing we did before, where we thought about what were the headers, what is the body format, and how do I need to handle the results. But otherwise, it's just boilerplate, and we just repeat the same thing. So we're going to try birds, and we're going to send it off, and we're going to see how it does. So once again, we are asking, in this case, to see what, pulling from the documents that we have. I have an idea for versioning these names, because I realize I keep naming everything how we feel about birds. But you can see that the job is in progress. Our Luigi task monitor will show us that this is in progress. We can take a look at the pipeline task that's being. Let me clear that out here. The pipeline task that's being worked on, and it's being analyzed, and basically it sent it off to Microsoft, and now it's done. So let's take a look at our results about how we feel about birds here. And there's more bird feelings this time from Watson. So let's see what Watson has to say. Watson found some different sentences, or we sent in some different sentences, or at least what I'm demonstrating here. She has no pets, no birds, no occupational exposures, and Watson comes back with some interesting feelings. It assigns some anger score to not having pets or birds. In this case, exposures to birds on a boat has some feeling. This one is probably the most accurate in a sense, which is that the patient is feeling down, misses being at home with his wife, feeding the birds, etc., reflecting a tone of sadness to some extent. At my own peril, I'll go ahead and just see what happens if we do the football work on this one. We're going to just change it to football. Again, happy to take suggestions for other things. And I'm going to go ahead and change this to how we feel about football, so we can at least finally, it'll make more sense. And then we'll run it again. So now what we've done is using, I just want to emphasize, by the way, that I could take this and I could just paste this into the result viewer, the NLPQL runner. So what we did here, I could have just pasted this in and just done it like that, rather than using the document. So how we feel about football is in the info phase. It's currently presumably sending things off to Watson to ask how we feel about football. And I'll take a look at the features that are back, and we do have some feelings about football. Once again, the football position, the football hold seems to be pretty common thing here, and it seems to be pretty positive. The infant is doing a little better, but it's kind of tentative there. Let's see if that any of the injuries showed up here. This guy's asking to watch football. Very positive, joyful. Here you go. Okay, so now we have our same friend who was struck playing football. This is all synthetic, or sorry, de-identified data, by the way. Our friend who was struck his head playing football, and you get this response where there's sadness in it as well, according to this. And you can also see, some examples of how you might use the results that come back from Blue Mix, and you would use them a little bit differently. So what we've demonstrated thus far is generating what we call intermediate data. We have gone and said we want to get some feelings about a sentiment in order to score something, and that is very useful. But it doesn't get us all the way to a phenotype, right? It doesn't get us all the way to where we might want to be. So let's take an example a little bit more in the medical world, and say we'd like to use these APIs that we just built over the last 30 minutes or so, and we would like to use them to build a phenotype for clinical purposes. So we're going to start with our basic sentiment analyzer here, and what I'd like to do, and I'm not sure. I found some the bird stuff to be somewhat mystifying. So I said, well, let's take a look at sentiment related to certain kinds of drugs, and I picked bisphosphonate drugs, both because they're generic, but also because they've been associated with osteonecrosis of the jaw and had a lot of negative press for some time. Statins might be another good example. But just thought, well, let's see if we can find mentions of sentences that contain these elements. Very basic. I'm basically passing in some terms and saying, let's find things that match it. I could do something a little bit more robust using some of the really cool implementations that we have. For example, looking at terms that relate to one another, looking at term sets. I could have found other, ways, but for this case, I simply said, if there's a mention of these in a sentence, let's go ahead and see what we think about that. And so we can send this off into the world and see what comes back. And so that's running, but I'll save you the time of going over to the thing and just say that we do get some bisphosphonate sentences back. Maybe is a bit easier to view in the viewer here. So we will now look at the bisphosphonate sentiments that are kind of coming back. This is using the API we just built, and it's generating features. And you can see in this case, we get some feelings about bisphosphonates, right? And again, these aren't necessarily feelings. This is just any sentence in which a bisphosphonate appeared, and you can see that there's kind of a mix here, but mostly they're just kind of miscellaneous sentiments about miscellaneous things. Now, what we want to do, though, in our case, is create a phenotype. We want to say, no, that's not quite what I'm looking for. What I want to find is I want to find patients with negative sentiments about bisphosphonates. And so I'm going to do the exact thing we just did without any changes, but I'm going to say I want to define a final result for so we use the word final to reference a output result. You noted before when I went through this that it kept saying no results, and then I would click over on features. Features are where we build the building blocks, the data extraction that you want to perform, where the finals are the ones that you say, this is what I want to output. Maybe it's a set of patients, maybe it's a set of documents, and in this particular case, I'm going to say I did context patient, maybe could do context document, but I'm going to just go out and say I want to go ahead and run this, and I want to see all people who are down on bisphosphonates as defined by a bisphosphonate sentiment score less than 0.4. So if you look at what I did, I just made up this word, bisphosphonate sentiment, and I assigned it to this function that we just created against this term set, which I also just made up, called bisphosphonates. I then said, I know there's a sentiment score that's going to come back. In this case, I want my final group to be those that have a bisphosphonate score less than 0.4. And so I'm going to go back and I'm going to take a look and see if I can have patients who are, looks like it's finished. I'm actually going to download it just because it's a little bit easier to see. I'm going to download the cohort here, and And what you can see here, and I'm going to blow this up so it's a little bit easier to see, is that I've got a set of people who have sentiment scores less than zero point 0.4. And when you looked at before, you may recall that we had quite a few scores. We had quite a few results back. But now these are just the ones that have negative scores. And you can see that I have people who are having someone who presents with left jaw pain and neck stiffness, got the lowest 0.06, did not recommend bisphosphonate, had a lower score, does not take Fosamax, question bleeding from esophagus, reports increased NSAID use, etc. We can look at this also in Clarity here. And what you'll notice is that for the first time, we're actually getting results back that are in this Explore area. And I can click here and it says, okay, yeah, for down on bisphosphonates, you've actually found a patient. Here's a patient ID, and you can take a look and you can explore the information. And this, in fact, is a patient who had a rule out jaw osteonecrosis in response to bisphosphonates. So in this case, we had a really, just a nice example of how we took an API that we just created. We got scores back. We built a phenotype that looked for ones that had low scores, and we discovered in this case a patient that fits really well the context of kind of something we're looking for, where someone had this osteonecrosis combined with it. So that kind of walks us end to end from thinking about an API, integrating into a custom task, creating and running that custom task, and then integrating into a phenotype, which we could then join. We did less than 0.4, but we could have done a join with structured criteria, as we've done with Odyssey, with unstructured criteria, or a much more complicated phenotype. Before we have our special sneak peek, I wanted to pause there and open up for any questions on the line. So, any questions from the phone or in the room?
Hey, John, this is Emilio. We've connected a little bit
Of
in the
course.
past. I'm just curious, how much do you think the use of these APIs from Microsoft and Watson are going to actually be hindered by PHI to run at scale?
That's a great question. I think I would say somewhat is a fair answer. I know that we generally there may be others on the line that can comment. I know that while you can have a secure sort of AWS setup and so forth, the kind of core APIs that they provide, you probably would, I guess, need some type of contractual or other arrangement to be able to hit those with clinical text. Certainly, a lot of the NLP we do here is on trial descriptions, NLP on drug labeling and other things where you could do it more easily. But I'm wondering, does anyone on the line or in the room have any thoughts about using APIs with PHI? I know that one of the things that Apple is trying to do with their new health kit is to have more processing done on the phone. So that actually minimizes what needs to go up on the cloud and provide more. And it may be possible that something like a sentiment analyzer or something like that could actually be done, kind of locally or spun up locally. But I think it's a very good point, and I don't have a simple answer, but I suspect some of these organizations maybe have started to think how they're going to deal with sensitive information, whether it's health or otherwise.
Cool, appreciate it. Yeah, for anyone that's interested, Google today signs a BAA to allow you to use their NLP stuff, including their Auto ML. Amazon and Watson do not yet. They're thinking about it, but haven't made it HIPAA compliant just yet.
Thank you. That's super helpful. That's great. We might even add that to the documentation here. That's really, really important point. Any other questions? Do people feel like at least they have somewhat of a sense of how they might go about taking a RESTful API from somewhere else and giving it a stab to integrate.
Yes, that was a very clear walkthrough and very helpful, and I love this system of having each cooking with Clarity notebook record all those steps so clearly. Is there also a recording of these sessions?
We do have a recording of the sessions. Hopefully, Charity has been able to get this recorded as well.
It was very clear as usual, John. This was great. And I'm assuming that the ability to specifically relate the sentiment to some object of interest, like the bisphosphonates or birds or footballs, is not a given, and that's going to depend on the API and what the particular algorithm is doing. Is that right, or are there particular tricks that one can do other than just assume that if bisphosphonates in the sentence and there's some sentiment score that it's about biphosphonates as opposed to other things also in the sentence?
Oh, yeah, that's a good point. I think that would be more API dependent. For example, if there were APIs that allowed you to pass in like your target term
Yeah.
as well as the text, I think that would kind of be more ideal than what I just did. Yeah.
No, I thought what you did was great. I was just assuming that, yeah, the two versions you showed didn't have that kind of target in it. So I assumed, you'd need one that did that. I just wanted to make sure there wasn't some trick you'd already discovered for how to kind of get that out of a less specified API. But this was very clear and very helpful.
Thanks. Yeah, and that's a great point. Well, I wanted to, and we'll actually think about how maybe we could source a bit of a catalog of APIs that have been integrated and how we've taken advantage or could take advantage. Before we wrap up, I wanted to give a little bit of a sneak peek to something that our colleague Shirag has stood up a first pass at an NLPQL editor, and we recognize that writing NLPQL is it's not too hard to like read NLPQL and kind of like understand maybe what the person's doing, or to copy and paste and tweak it, which as you saw with football and birds and so forth, it's pretty easy to do, but it can be tough to generate sort of de novo NLPQL. So we've kind of created a first pass in an editor just to make life a little bit easier, so that the syntax and so forth isn't what's tripping people up. So I wanted to show what that NLPQL editor in its first instantiation looks like. And what you can see here is that there's some different parts of an NLPQL. The documentation under our read the docs has an explanation of what the different pieces do, but this kind of helps walk you along a little bit. So with any, so if we wanted to kind of recreate what we did before, how I feel about birds and version 1, and we would add the Clarity library, which right now is the only one that we automatically import. I've now got all these possibilities in front of me where I can say I want to create a term set. So I'm going to create a term set, and we'll call it birds, and we'll do bird and birds. And it now created a term set for me, bird and birds, which is great. I could make a document set where, for example, I wanted to say, let's do nursing notes, and I could say I want to create, take all notes that are labeled as nursing. Or if I'm at a particular institution and I know something has a note type that's called CXR to view or something like that, I could create that as well. And so we are able to basically automatically create that document set without worrying about the brackets and all the other stuff that goes with it. I could then define a feature, and so just like we did before, we could call that feature bird feelings, and we could pull the documents. I don't think we have the custom ones in here yet, but we will. The one that I just wrote. But say we wanted to do something like running a provider assertion, looking for certain terms. I could do that, and it provides me here in this case what are the elements that I might pull in. So I could then just go in and edit and say, okay, I want to put in nursing notes, and I want to put in birds as my term set, and I could use the other elements, or I could just not, and I'm going to just say I'm not. Again, but you can see what are the kind of options you have, and so we now have bird feelings, and if I wanted to create the result, I could basically say I want down on birds, and I could do where bird feelings. In this case, I'm doing a little bit more manual here, less than 0.4. So it's not automatically writing your whole thing, but it does make a syntax kosher version of that NLPQL, and it kind of walks you through, and we'll evolve that over time. But we're really excited and grateful to Chirag for taking the kind of first pass and beginning work on something that we hope will make it much easier for people to both edit, tweak, but also just lower the barrier to generating NLPQL and working with Clarity more efficiently. So any questions or thoughts about that NLPQ editor, or more specifically, feedback and ideas for how we can make it better and useful?
One thing you might do is maybe color code or somehow indicate which elements are optional and which are required.
Yep.
These function.
Yep. Yeah.
That'd be pretty useful.
That's a great point. So maybe color coding at the top level, and then maybe on the forms that pop up have some type of required piece. Yep. Other suggestions that might be helpful would be helpful to have the like a link to the documentation or something next to the different pieces, info.
Yeah, if you could overlay when you hover over it.
Hover over and explain what it is. Okay.
Maybe a right-click function that suggests things from a list. If there's sets of cohorts or something one might choose from that have already been defined, that you can pick from a list, so it'll add the name if they're in general when there are pick lists that are relevant for things that have already been defined that would make suitable arguments in the NPQL.
That's a really good point about ultimately having the history of things that have been created to expedite the process of generating. That's a great one. Yep.
And this looks extremely helpful, I have to say. Somebody who's just about to start learning all of this, I'm really happy to see this here. This looks like it's going to be extremely useful.
Thank you very much, Andrew. Thank you for everybody for joining. As you know, these cooking sessions, we design them to tackle questions that are on people's workload right now. So we have many people who work here who are also students and are doing projects, and they bring ideas. We've got clinical research projects that we're doing, but any of you that might be working on something and say, hey, could you take a tackle at how you would figure out this particular question or challenge, please send them along. I put Charity's email there, but also we've got our Slack channels or other ways. Please pass along ideas for cooking sessions. We have them every other week. Our next one is going to focus more on at least part of it around ingestion process, but I think there's a good space in there also to tackle questions, whether they're clinical, whether they're clinical research, clinical trials, or other types of unstructured text, and how you might work with it. We invite ideas, and I would really be delighted for those to be part of the discussion. So any last questions before we wrap up today? All right. Well, I want to thank everybody for joining, and we appreciate everyone providing feedback, and we're really excited to have more and more people on board and working with Clarity, doing really cool stuff and helping us make a better platform. So thank you very much, and have a great day.
Thanks so much, John.
Thanks.
Thanks, John.